Welcome to the new neuron video. The topic today keeps me really excited. Since I started with AI image creation, I wanted to try to create something you see on the background right now. Such strange, crazy, morbid, morphing skulls with sinew and teeth and skulls and all morphing crazily into each other. It looks like a crazy bad trip hallucination. Some days ago I started to work on the workflow and it really came out quite nice. I really love the results of it, and so here we are, and I will show you how you create such crazy animations. The only downside working with AnimateDiff is for sure the limited VRAM. If you have a small GPU, you might run into trouble quite quickly. If you tried AnimateDiff before, you might know that this workflow is quite heavy, but give it a try and start low on the resolution. I will go into the settings during the video. Hope you like it. I hope you are not too scared of the animation I'm showing you right now. And yeah, let's jump in and create this strange, magically weird animation. This is the whole workflow, and we have different sections. We have the AnimateDiff section. Above here we have our sampler, we have a ControlNet section, we have our normal prompt and model loader, we have our IpAdapter section where we load some images. Here we have a little upscale section and interpolation nodes to smooth everything up in the end. That's about it. Let's start with a normal AnimateDiff workflow and then integrate IpAdapter, ControlNet and the other things into it. Let's load our checkpoint. I choose deliberate 5. We need our prompts. And we need the case sampler. The latent image. For this today I use the 288 to 512 because this workflow can use a lot of VRAM, so you have to be careful to fill it up too fast. So we are starting with a quite small latent image, a batch of 64, so we will generate 64 frames with AnimateDiff. We might change this later to play around with it. We need our VAE decode. I will do a separate VAE this time, and then we create a video combine node from the VHS package. There are lots of custom nodes I will use in this tutorial, so be sure to install it before or on the way when you're creating it. I will link everything down in the description below. Connect our model. So now this is the standard workflow. So now we create the AnimateDiff section. We take the AnimateDiff evolved custom nodes, connect it to the model port, and connect our model to the AnimateDiff loader. We use the SD version 1.5 version 2 and keep this auto select. We load some context options. We need the context options views only VRAM node, and then we load the actual context options. I use the looped uniform settings. I keep this all default. This section here tells AnimateDiff how it should loop and process the sequencing inside. I use this type of context options to get a quite smooth movement animation. There are other types you can see on the AnimateDiff evolved page which use different approaches, and there are some animations which show you in a good way how this animation settings work. If you're not sure what way of looping animation you want to use, check out the custom nodes page and you will find more information on this. This should give us a basic AnimateDiff workflow. For the prompt, I use the following: skull smiling, decay, high quality photo, 8K, cinematic lighting, psychedelic fractal high detail creature. I gave the creature keyword a little bit more power. You can do this by activating it with your mouse and pressing Control and the up and down keys. So this gives this keyword more influence than monster, LED lighting, fog, sinew, lightning, wisps of smoke. So that should be it for now. As a negative prompt, I choose the following: worst quality, low quality, and yellow to filter out some unwanted things. Let's give this a try if we can generate something with it. So these results are quite promising already, but I want more control. As a first thing, I will integrate the IpAdapter part of the workflow. So it will go here in front of the AnimateDiff loader. Let's create the IpAdapter advanced node. This is using the newer implementation of IpAdapter. It's called version 2 or something like this. So be sure to update this. It's also using the busy air nodes. Be sure to install this too. Let's connect our model to the IpAdapter and connect the IpAdapter to the AnimateDiff. So this goes between the checkpoint loading and the AnimateDiff to load the clip vision. I go with this with H clip vision. Let's load the actual IpAdapter model. I choose the IpAdapter Plus for Stable Diffusion 1.5. So now we need our image. We need to prepare this image for the clip vision. And then we can load the actual image. For this, I take this cow skull. There are ways to load several images as a style base for your animation. But for now, to keep it simple, I only load one image. So this is actually the IpAdapter part of the workflow. This should fundamentally change the animation, so let's give it a try. The images I use for the IpAdapter I usually download on the Wikimedia Commons page, where you can find lots of open source images which can be used everywhere you want. So no licensing issues. So as you see, this changed the animation quite rapidly. So let's reduce the weight of the IpAdapter. I choose 0.2, go quite low, give it another go. And you see we are coming back to our original animation, but with more influence of the image we just loaded into the IpAdapter. So play around with the weight of the IpAdapter. Also try, you can load several images, for example, with batch images. So simply duplicate your image and load another one, and yeah, then you have influence of those both two images, so the style of both images get copied. Let's quickly give this a try. I like the results very much. Let's now get even more control over the animation with the ControlNet, so we can have more control about the movement and how the animation evolves. For this, we will access the path of our clip encoders of the prompt, and we will create an apply ControlNet advanced node. And simply put it between our prompt and our sampler. we need the ControlNet loader. I use the Canny ControlNet loader here. I saw many people use a QR code ControlNet. For now, we will use the Canny ControlNet. We want to load a video. I will show you how you quickly generate such videos for the ControlNet in Blender in the next video. Yeah, let's connect it to the image input, and let's do a preview image here that you can see what kind of video I use. So this is a video I created as a ControlNet. It's simply a wave texture which is moving down. I will show you how to create such texture-based animation ControlNets in Blender in the next video. So the video is in our ControlNet Advanced. Let's keep the strength at 1 and let's give it another go with the ControlNet included. So you can clearly see the ControlNet at work there, but it is too much to give the animation enough space. We will reduce the power of the ControlNet to 0.5 to still get some motion, but not kill the animation totally. This can be wanted depending on what you want, so it depends on you, what you're aiming for. So play around with this value, play around with the type of animation you load. Let's give it another try with less weight of the ControlNet. So there we go. It gives the animation a quite organic look, movement everywhere. I really like it. It's quite organic. Yeah, this is something which is really fascinating for me, how such animation gets created. AnimateDiff is such a powerful tool. Since we have done the IpAdapter and the ControlNet, we need some upscale and we want to integrate some interpolation. First, do a simple upscale using a model. I will use the 4x ultra sharp upscaling model. Connect this to the images input of the video combine node. Let's directly include the interpolation. I use the film interpolation type, put it in here. I choose the multiplier 3, the rest stays standard. What I want to do is I want to change the video combine node settings, frame rate to 12. I also want to create MP4 H.264 files. That should be it. Let's try. So here we go. This is much smoother and slower. Might be too slow. So we could reduce the multiplier value or increase the frame rate value. It got upscaled as well. I'm not totally happy with the quality and there are some artifacts. So in a future video, I might include some refiner or some different upscaling workflow to get better results with this, but I think you get a glimpse how you can work with this. Let me maybe quickly go into the important settings again, which are important to get the full control of the animation. Let's start with the IpAdapter. To keep it simple, most important is the weight value. Also important is which kind of model you use, but for me the weight value is the most important for this workflow. We have the apply ControlNet, where the strength and the end percentage is quite important. Play around with those values. For sure, we have our prompt, which is maybe the most important thing depending on how much power you give to the IpAdapter. We have the ControlNet area where you can choose different ControlNets And for sure, the video you use as a ControlNet is very important. Adjust the strength of it here. That's quite important too. This is very important. For example, I tried to double the resolution of this and also doubled the batch size, and I ran out of VRAM right away. So this is also important to keep in mind. If you have problems with the full VRAM, play around with our settings. You might have to do it smaller, you might have to reduce the batch size. That's quite important. Then for sure, depending on the model and the results you want to get, the steps and the CFG. Then the upscale model is quite important, and you can play around with the multiplier value in the interpolation, and that's it for now. So be sure, if you don't have a big GPU, start with low resolution. Maybe you have to skip the upscaling or the interpolation, but the most action happens here in the case sampler. So if this is smaller and the batch size is smaller, you might get better results and no error messages for small GPUs. I will upload this video on the Patreon page as a package with the IpAdapter style sources and the ControlNet video, and that should be it. Next time I will show you how you easily create such abstract ControlNet videos in Blender, and after that I will create more animations with AnimateDiff. Stay tuned. Like the video, support me on Patreon, and I hope I will see you soon here on the channel. Goodbye.